Hi, I am YVS Y Venkateswara Swami. In my previous classes, I have explained construction of electrochemical cell. Construction of electrochemical cell. Electrochemical cell and its working also we have seen. How does it work? Mechanism of the electrochemical cell. How does it work? To produce current only. These electrochemical cells are used to produce electricity by using spontaneous reactions. Okay. Now, how to calculate electricity quantitatively produced by these cells? Now, today we are going to talk about quantitative calculation. Quantitative calculation of current produced. This is a topic today for senior intermediate students. For competitive examination also, this takes play very important concept it is. So quantitative calculation. As we know that left side anode, always there is a convention, right side cathode. In the case of Daniel cell, we have left side zinc rod, right side copper rod. This is anode, this is a cathode. This is cathode, copper rod is a cathode. A zinc rod is a anode. And their respective salt solutions. The respective salt solutions are there in the solutions which are connected by a copper wire. Okay, you know all these construction I don't talk about again. And these two are connected by salt bridge. Okay, this is the simple construction of a Daniel cell or any electrochemical cell. Left side we take anode, right side cathode. Now how to calculate we know that every electrode gains some electrode potential between that rod and solution. Between the rod and solution there exists some electrode potential. Anode gets a negative charge, cathode gets a positive charge as a result of this reaction, chemical reaction. So this is a negative electrode, positive electrode. Negative electrode potential, positive electrode potential on the right side cathode. Now, what is the electrode EMF of this cell? Potential of the cell means formula is there. E of the cell means potential of the cell. E means potential or simply cell, but actually called EMF. Electromotive force of the cell. Electrostatic cell formula is E of the right. E of the right means this is means nothing but cathode. Cathode electrode potential minus electrode potential of anode means left. Means this is a anode. This is the formula. In the examinations, they will give these values. Simply application of this formula, we can calculate the electromotive force of the cell or simply potential of the cell. This is. But what is the problem here? We are not talking about the concentrations. And one more problem is we cannot calculate individual of cell potential. We cannot calculate potential of the individual or independently one of cell. Then we should have some other method to calculate. What is that? Then by using we are using SHE, standard hydrogen electrode. It is called standard hydrogen electrode. SHE, in short SHE. By using this, we can calculate any potential of any of cell. That is, how do you construct this SHE? How do you apply in the cell? Let us know. Okay, this is prepared by taking vessel, and platinum electrode we take, it is dipped in the platinum electrode. In where it is dipped? It is dipped in acidic solution whose concentration of H plus ion is 1 molar. 1 molar acidic solution we take, molarity 1, and this is a platinum rod dipped in this acidic solution. This is from outside we send H2 gas, pure H2 gas into this, with 1 bar pressure. 1 bar pressure. This is important condition for constructing standard hydrogen electrode. So this is called SHE. Here bubbled, hydrogen gas is bubbled at 1 bar pressure, bubbled through this acidic solution. So at this condition, it is called SHE. At all temperatures it works. We can take at all temperatures. But what is the special of this important thing about this? Its E value is always equal to 0 volts. Its E value is 0 volts. Taking this advantage, we are able to calculate the standard electrode potential of any other cell. This is a reference. This is also called reference cell. Now, this reference cell always takes on the left side. Reference cell always takes on the left side, means hydrogen electrode. Standard hydrogen electrode taken on the left side only. Standard SHE taken on the. It is a convention. It is a convention to take on the left side. This SHE. We cannot take on the right side. So it is a convention. Why? If you take like this only, we get always the potential of the cell, entire cell will be positive. Okay. Now, any of cell you take on the right side, any of cell containing any other solution dipped in their respect to any cathode or any metallic rod dipped in their solution. These are connected by salt bridge and copper wire. Now, here what is this is right side means cathode. Cathode. This is anode. SHE is always taken as anode. That is fixed. Never confuse. Okay, now, but its value is 0 volts. That value is 0 volts. Potential. That means potential value. Therefore, we get what is the formula? E of this cell is E of the cell is equal to E of right. Right means cathode minus E of left. So this value will get something, that is E of the right, we get something, but minus 0. It means the cell potential of this is equal to cell potential of the electrode potential of the cathode, nothing but because this is minus 0, we get same only, that is E of the right only we get, E of the right. Right minus left. Left is always 0. SHE. So E of the right is nothing but potential of the cell. This is the way to calculate the standard. If you take other of cell also at the standard conditions, we get E naught of the cell. If you take at a standard condition, we get E naught of the cell. Not means standard conditions. That only given in a list. In your NCERT books, given a list of these E naught values. These values may be positive or negative. In the case of hydrogen, it is its value is 0. So this is the way to calculate, and always the cell potential we get only positive value. This is the way. And in the next class, I will tell how to calculate, how to represent the cell. How to represent the cell. Representation also is important. Means left side anode, right side cathode. Right side. For example, Daniel cell representation. How do you represent a Daniel cell? Zn on the left side, Zn gives Zn solid gives Zn plus 2 ions on the left side. It means metallic rod and its ions are separated by a vertical line, a single vertical line, and double vertical line represents salt bridge. Right side what happens? Cu plus ions, these are aqueous, and Cu plus aqueous ions become Cu solid. This is the cell representation. Also most important point, cell which of the following correct representation of the cell type of questions you will get. So everybody should know that in my already you know that left side always more react to metal. For example, if you take copper and Ag, silver, copper is more reactive than silver. So copper is taken as in this Daniel cell copper is cathode, but in this we take copper as the anode. It depends. What is the anode, what is cathode, it depends upon its reactivity. More reactive, less reactive. Two metallic rods if you take, more reactive material is always the anode, less reactive cathode. That is. So, we meet in the next class. Thank you. Hi all of you. I am YVS Chemistry. Second year organic chemistry for the students appearing for competitive examinations and academic also, both IIT mains and advanced and NEET level. From grassroots level, we should study the subject. Theoretically, you should be strong as well as numerically also. Whenever you are very strong theoretically, definitely you will be strong in numerically also. Generally, most of the students avoid theoretically, but it's not correct. Now, let us talk about the feasibility of SN1 reactions. Feasibility in two compounds. Let us what type of reactions take place, or what type of mechanism? What type of mechanism in what type of mechanism is in two compounds I am giving, that is allyl chloride or allyl halide. Second one is benzyl halide. Benzyl halide. Are these suitable for SN1 mechanism or SN2? We have to decide. SN1 or SN, there are two chances, SN1 or SN2. Which is more feasible, SN1 or SN2? We should know that SN2 reaction takes place in a single step, SN1 two steps. SN2 reaction takes place in primary alkyl halides. This is a tertiary, because of the stability of carbocation. So, SN1 or SN2 depends upon stability of carbocation. Stability of carbocation. Carbocation means a compound which contains positively charged carbon atom. Carbocation means formation of carbocation. Carbocation formation results SN1 mechanism. More stable carbocation, more stable carbocation results or undergoes SN1 mechanism. Undergoes SN1 mechanism. Why? Because in SN1 mechanism, carbocation forms in the first step, slow step. So there is a possibility of formation of carbocation in allyl halides. First of all, you should know the concept of allylic concept. What is allylic? A sp3 carbon atom which is bonded with a sp2 carbon atom, that is allylic carbon. The carbon with sp3 hybridization when bonded to sp2 carbon atom, that is a allylic compound. For example, let us take CH2 double bond CH2 CH2Cl or Br. This is allyl chloride. This is a sp2 carbon atom. This is a sp3 carbon atom. So a carbon atom, sp3 carbon atom which is bonded with sp2 is called allylic carbon. Allyl carbon. So this compound, when it loses chlorine, what do you get? Because this is a polar bond, this leaves, leaving group Clr or Br, chloride or bromine leaves out, resulting CH2 double bond, CH single bond, CH2 positive charge. This is a carbocation. So this is a important reaction or important change that take place in allylic halide. After leaving this chlorine, we get a carbocation. It is stabilized by two resonance structures. So it is suitable for SN1. A compound in which carbocation is stabilized by some reason, that is that undergoes SN1 mechanism. So definitely it has two resonance structures. Resonance structures are represented by double-headed arrow mark. Yes, what happens? This double bond comes here, positive charge. So this left side CH2 get positive charge, this bond becomes single, and this bond becomes a double CH2. These are the two resonance structures of allyl chloride. So carbocation stabilized by two resonance structures, so that undergoes SN1 mechanism. For any higher level of examinations in India, this is very important concept. In the same way, benzylic halide also. What is the reason here? Why allylic halides undergo SN1 mechanism? Because from allylic halide, allylic carbocation forms, it is stabilized by resonance. These 2 points you should keep in your mind. Next, benzyl chloride. Benzyl chloride, it also stabilized by resonance structures. Here are two resonance structures. Let us see, in the case of benzyl chloride, how many resonance structures it will have and how it is suitable for SN1 mechanism. Let us see. Benzyl chloride on benzene ring, there is anywhere we can write CH2Cl. Benzyl chloride, its name is benzyl chloride. Okay, what is here? When this leaving group Cl goes out, what happens? We get a carbocation on the benzene ring, CH2 plus carbocation. So then nucleophile attack takes place. After formation of carbocation, nucleophilic substitution takes place. Nucleophile will attack there. Here also it is ready for nucleophile will come to this carbon atom. Before coming, it undergoes resonance structures. How many? Let us see. Because this positive charge, these pi electrons will come to here. Then as a result, we get a resonance structure like this. Here a double bond comes, here CH2. Positive charge is disappeared, vanished. Now here positive charge, here as usual double bond. S. Now second, these pi electron come to this as a resonance. Then we get another resonance structure like this. Here positive charge comes here, here a double bond, here a double bond only CH2, and other double bond here. Now then what happens? These pi electrons come to this, here positive charge comes. Next, what is the resultant resonance structure now? The resultant resonance structure of benzyl halide is like this. Yes, as a result of this polarization of the electrons, next resonance structure of this compound we get, yes, this has gone positive charge. So these electrons gone, positive charge came here, and these electrons will come here. That is what happens here, positive charge forms. Here a double bond CH2, here double bond, here a double bond. Again one more. How many? 1, 2, 3, 4 only. Again what is one more? these seeing this positive charge, these pi electrons come to this side. As a result, we get yes again here positive charge. Like first structure, this is structure. This is structure here on from here only resonance structures. Now, what are other bonds? Yes, other bonds are like this. Yes. What is the difference between the first structure and this structure? First structure, just position of the double bond in the ring only changed. Even though there are resonance structures only. Total how many? 1, 2, 3, 4, 5 resonance structures. So greater the number of resonance structures, greater the stability. Greater the stability, greater the feasibility of SN1 mechanism. So whenever you get these compounds in the examination, you should remember that as a result of resonance, these two compounds undergo SN1 mechanism. I hope you have got the point. Again, if any doubt, if you like this, please subscribe this and share this also. My number is again I'm 9010938939. Any suggestions or any concept you require from my side, I will explain if you do phone call to me. Thank you.